Hello all, welcome back to Aislyn Technologies YouTube channel. Today we're gonna see about neural style transfer. The purpose of this project is to investigate NST by analyzing its effectiveness through qualitative and quantitative metrics, focusing on image style and loss functions since there is no direct accuracy metrics. Here, a methodology is we are using six approaches were examined with one model featuring five ReLU layers and achieving the highest structural similarity index score, indicating a strong alignment between content and style. Our significance is to find highlights NST versatility and potential applications in democratizing art and enhancing creative process. Our introduction summary that our project examines how NST can replicate artistic styles, making art more accessible to the public. This NST mechanism involves two images. One is for content and one is for style to produce an output that retains the main feature of the content while adapting the style. The traditional method requires extensive practice, but NST simplifies through this AI. Advantages in NST is in recent developments allow for using a single style reference image, streamlining the process compared to earlier method that were time consuming. In NST has many applications. It has been used in various fields with including image and video editing, virtual reality, gaming and commercial art. Our objective is to rural trail transfer using CNN is to combine the content of one image with the style of another image, generate a new image that preserves the schematic content of the original content image while adopting the visual style of the style reference image. Neural style transfer using CNN can be applied to both image and video. I will explain you the flow chart now. Yeah, this is a workflow. What we are doing is first we will have a data set. And then we'll be preposing all the images in the data set. By using BG16, we will extract the features from the image, and we will train these features. We will train these features, and then the model will be saved outside. The saved model will be dumped to the main code, that is testing code, and it will convert the image into neural style. Now I will show you our code. Before that, I'll show you a data set. So this is our data set. It could combine the both image and produce this new image. Now I will show you the code. This is our neural string transfer code. Yeah, these are the important libraries we are. Yeah, these are the libraries we have imported here. Uh, Time is nothing but for measuring the time taken for each iteration. And then TensorFlow is nothing but for loading and building a deep learning models. For image, I was to operate image to input output path, and NumPy for used to numeric operation. Like this, all the packages are used here, and these are the important packages we have given here. So this BG backend is for a flow level transform operation, and this is for to optimize the loss function, and BG16 is implemented here. So here we have pre-trained, here we imported a V16 model. It's a pre-trained model. And from keras dot from TensorFlow dot keras dot preposition dot image, we're importing load image and image to array. Here we have gave our Japanese art image, that is our structural image, and this is our style image. Based on this style, our structural image will be changed. Yeah, these are dimensions we are predefining here. Yeah. Here, by using our dev pre-process image, we are importing our image here, we are original image, and we are changing our original image to array to give into our BGG16 model as an input. And here we are doing deep processing here. That is, it will Here we are doing deprocessing. It converts the processed image back to its normal range and form a BGR to RGB format. That's what we are doing here. And then these are used for loss function. So this content loss is used to measure how much final image deviates from their content target content image. And gram metrics is nothing but which captures the style by capturing spatial correlations between the feature maps. And style loss is used to the loss between the style of the reference image and generate the new image. This total variation adds the penalty for spatial noise in the generated image to ensure the smoothness. And then here we are loading here the images are pre-post content as style, and it is for place, and this is for a placeholder which contains our final image, which contains a final image here. And then input tensors combines all three images into a single input tensor for a BG16 model. And here's our model. This V60 pre-trained image. This is a pre-trained on image.net dataset with a three image input. Yeah. Here, our output directory. Uh, these are the layer names on the corresponding outputs, and our content loss is nothing but we are using block file to extract our feature maps, and style loss using for feature maps from the multi-layer. And here our total loss, indicates that our content loss and style loss of the total variation loss to the smooth image. Here, we are doing a gradient calculation and optimization. In grants, the gradient of the loss with respect to the generated image. In evaluator, a class that returns the current loss and the gradients. Here, and then finally we could use LBFGS optimization. The function it minimizes the loss by adjusting the pixels of the generated image. That's what we do in here. With iterations of 10, it will be generated, it will be run over 10 iterations and saving the image for the each iteration. Yeah, now I'll run this. You will know how I'll run this, you will see the output. Now I'll run this, you could see the output for this. Yeah, now our program has been successfully run. I'll show the output now. Yeah, this is output. This is output. I have given 10 iterations now. For every iteration could generate for output here. So, so this and this I have like combined so that I have got output of them. Yeah. Thank you for watching my Aislyn Technologies YouTube channel. For more Python videos, follow Aislyn Technologies YouTube channel. And don't forget to like, share, and subscribe. Thank you.